Hello everyone, welcome to the channel. So in this video I'll be telling why index compression technique is required. So usually before this we will deal with how to write the posting list or the inverted index for any given word present in the query. So while we are writing the posting list or the inverted index for any given term in the query, it takes lot of space and more amount of complex things are involved. So to reduce that, and we can store those things in our systems, so compression techniques are required. So here you are able to see in the screen that it uses less disk space. It also saves a little money as well, keeps more stuff in memory, increases speed also due to caching of more data. So cache is nothing but the high speed memory of primary. Now increase speed of data transfer from disk to memory. Okay, so for these things, index compression are required. So why compression for inverted index? So dictionary, make it small enough to keep in main memory. Means how much it is required, only those things you are going to keep it. Now make it so small that you can keep some posting lists in main memory too. So like when we are writing the posting list, it might go up to the infinite length also. So even when we go it to the infinite length also, we should be able to store those things in our main memory. So for that, compression technique are required with respect to dictionary. Now when we are coming with to the posting files, now reduce disk space, decrease time which is needed to read the posting list, and large search engines keeps a significant part of posting list in the memory. So for these reasons we require compression for the inverted index. For example, we are going to take a document from Reuters RCV1 document. So documents, there are 8 lakh documents, and average number of tokens present per document is 200. So terms, word size, that is, it's going to be 4 lakh words. Average bytes per token is 6. Means if you include spaces and punctuations, everything, it is going to be 6. Without spaces and punctuations, if you remove, average bytes per token is going to be 4.5. Average bytes per term is 4, it is going to be 7.5, and non-positional postings is going to be 100 million. Now observations. When we come to the observations, pre-processing greatly affects the size of dictionary and number of posting lists. As the size of dictionary increases, number of documents increases, the number of posting lists will also increase, and more amount of time will also take in writing the posting list for each and every word present in the query. Now stemming, case folding, stop word removal, everything. So stemming in the sense basically removing the end part of the word. Stop word removal means take a given document, remove all those articles, prepositions, everything and fine tune the document. So that is what you mean by stop word removal. A percentage reduction can also be different based on properties of collection. Now lemmatizer for French reduces dictionary size much more than porter stemmer for English. So this lemmatization and stemming, these are all the techniques which are used. Now index parameters. So this is just an example which is given. So dictionary size 484, delta percentage, nothing, cumulative percentage, nothing, 474 minus 2 minus 2, 392 minus 17 minus 19, 391 minus 0 minus 19, 322 minus 17 minus 33. So this is for word types. When we consider for non-positional posting list, this is how we are going to consider. When we come across the posting list, we will be dealing with these things. If it is unfiltered, then there is no change. If there are no numbers, from there we are going to see the changes. Now coming for the lossless versus lossy compression. So when we are going to deal with index compression, since when you consider any search engine, they will deal with more number of documents. Might be the amount of query is less, but the number of documents which are processed are more, right? So compression is required because we have to write the posting list for each and every word, means in which document, in which website, and at which position, and at how many times it is present. So everything we are supposed to consider. So we will go with the compression. The search engines will go with the compression technique. So here compression techniques are of two types. One is lossless compression, another one is lossy compression. So what is lossless compression? So lossless compression means after performing the index compression also, all information is preserved. Means what we mostly do in the IR. And lossless compression will have an added advantage. because even after compression also we will be storing each and everything it is present. How the document, how the posting list was before, the same thing we can retrieve it, we can get it back in the same format. Lossy compression means while compressing itself some amount of information might go off. So this is the disadvantage. This should not happen. Makes sense when discarded information is unlikely to be ever used by the IR systems. Means if it is not relevant to the IR system, if it is not useful to the IR system, then lossy compression makes sense. But if the discarded information is useful, which is very important, then lossy compression should not be used at all. So several of the pre-processing steps can be viewed. So lossy compression means case folding, stop words, stemming, number elimination, all these things. All these techniques will come under lossy compression. So this was the introduction to the compression techniques. So in the upcoming video, I'll be explaining in detail what about dictionary compression, posting list compression, everything I'll be explaining in detail. With this note, I'll be ending the video. Thank you.